it set up where you can spend as much time as you want on this test review. It's not timed. When you do submit your answers, it will give you whether they were correct or not with the right answers. But if we do this together, then that's neither here nor there. I'm looking around and just kind of seeing a couple people still logging in, so I want to give them a second. All right, let's look at number 1. So we've got the scatter plot showing the relationship between percent change in population of wolves and the moose density and number of moose per square kilometer over a 19-year period in a certain region. Notice that the association is negative and that the points seem to be more spread out at higher. We call this fanning, by the way. Spread out like a fan. It's called fanning or coning. Suppose the variables in this scatter plot were reversed. In other words, what if I put moose density on the y-axis and percent change in wolf population on the x-axis? And it says that. Which of the following would be true? Well, right now, as the moose density increases, the percent change in wolf population decreases, and we can see that it's got a negative association. What do you think will happen if I just flip-flop those? And if we had enough time, if we weren't crunched for time on the AP exam, we could maybe sketch this out, plot some ordered pairs in reverse, and kind of see what's going on. But the idea here is, as one variable increases, the other variable is doing the opposite. When I switch them around, the same is going to be true. The same thing is going to be happening. Moose density is going to be increasing as wolves are decreasing. So do you think that that's going to change whether the association is positive or negative? What do you guys think on that one? This is kind of a conceptual question. Silent 6th period. Do you think that the association would still be negative, or is it going to change to positive? Let's start there. It's going to stay negative, okay? Because these are still doing the inverse of each other, even if you plot them backwards. So the association's not going to change. Will the strength of the relationship change for any reason? Are those dots going to be, more linear in nature? Somebody's shaking their head? No. So nothing would actually change about the direction and strength. R would still be the same. So what answer choice is that? E. This is going to be brutal if you guys don't participate with me a little bit more. Let's move on to number 2. I really don't think you need my help with this one. For which of the following scatter plots is the correlation closest to -1? This is like very, very basic skill level here on this one. It is E for sure. A is closest to +1. E is closest to -1. Why can't it be C? Because I still want you to understand that correlation doesn't have to be linear. So why can't C have a correlation of -1? That's that weirdo graph that we talked about. See how it's like parabolic in nature? So this doesn't even have a correlation. The correlation is 0 because it's decreasing and then also increasing. That's weird. So that has a correlation of just 0. Even though you can clearly see the pattern, that's not going to be the one. All right, let's move on to number 3. There's not any calculating to do on this one. Jacques, an artisan cheesemaker, collects data on every step of the cheese-making process for each batch he makes, and he noticed that the daily high temperature in his shop on the day he made a batch of cheese was related to the pH of the cheese the next morning. He computed the correlation between the daily high temperature and the pH, and he found it to be negative 0.64. So think of this, negative correlation. What information does the correlation provide about the relationship between the daily high temperature and the pH of the cheese? The daily high temperature would be explanatory because it might help explain the pH. A says the relationship is linear because the correlation is negative. There's everything wrong with that one. That one's definitely not it. The relationship is not linear because the correlation is negative. Those aren't even related to each other at all. C, the morning pH of the cheese tends to be higher when the daily high temperature is higher. That means as temperature increases, so does pH. Well, that would be a positive relationship, so that's not it. D says the morning pH will be higher when the daily temperature is lower. That is one is increasing while the other is decreasing. I like that one. And then E says there is no relationship. There would be maybe no relationship if the R value was 0, but there definitely is a correlation here. So we're going to go with, what was it again? D. Very good. Number 4. And I know I'm moving really slowly for some of you. You can work ahead. A certain middle school opens at 7. Classes begin at 8. A sociologist gathered data on the number of minutes after 7 that a student arrives at school and the number of friends the student has on social media. Seems like kind of a weird thing to try and connect, but the correlation between the two variables indicated a strong negative relationship. Which of the following is an appropriate interpretation of the correlation? Strong negative relationship, which means as one is increasing, the other is decreasing. So if I look back here, as the number of minutes after 7 that a student arrives at school increases, the number of friends that is predicted will decrease. So A says, students who arrive early have more friends. Well, that's a causation statement. That's not necessarily true. Students who arrive late to school have more friends on social media. So again, that's causation. That can't be it. C, having a lot of friends on social media causes a student to arrive late. Nope, causes. D, as the number of minutes after 7 increases, the number of friends on social media tends to increase. Well, they're not both increasing. And then E, as the number of minutes after 7 increases, the number of friends decreases. I mean, you could sail right through this problem. If you see up at the top, it's got a negative relationship, and you can pick the one that says as one increases, the other decreases. Pick E and move on, okay? All right, this one looks a little more mathy. Bankers at a large financial institution created a linear regression model, D hat equals 0.37 minus 0.0004S, to predict the proportion of customers who would default on their loans. That's what D is, the proportion of customers who would default on their loans, based on the customer's credit score, S. For a customer with a credit score of 700, which of the following is true? So I would pick up my calculator and I'm going to plug in 700 for S. I'm getting 0.09, so I think it's A or B. The difference between A and B is A says that it's predicted to be 0.09 and B says that it is 0.09. So out of those two, what is it? Yeah, it's predicted to be 0.09. Very good. I would consider that one pretty easy. Let's move on to number 6. A marketing consultant, Sophia, has been studying the effect of increasing advertising spending on product sales. She conducts several experiments, each time spending less than $1,000 in advertising. So as she's gathering her data, she's spending less than $1,000 each time. When she analyzed the relationship between X and Y, she saw this linear relationship, and R is 0.9. That's very strong. Her boss is thrilled and asks her to estimate product sales for $100,000 in advertising spending. Is it appropriate for her to calculate a predicted amount of product sales with advertising spending of $100,000? Yes or no? No. Why? It's too much money? I mean, yeah, I mean, so she's gathering data, and every single time she does it, she spends less than $1,000. So whatever she tells her boss is probably going to be way unreliable. What's that called again when you plug in a data value that's far outside of the other X values? It starts with an E. Yeah, extrapolation. So she's extrapolating here. So it's no, because 100,000 is much greater than the values used in the experiment. That one's kind of cool because you don't even have to remember the word extrapolation. Number 7. Do we like this residual plot? Is this a good residual plot? Yeah, I don't see any pattern there. There's no fanning, there's no curvature. So based on this, is it reasonable to conclude that a linear model is appropriate? We know that it's yes, so let's look at the difference. Yes, because the plot shows no apparent pattern. Yes, because the points display less variation as x increases. Or yes, because the sum of the residuals is close to 0. Don't overthink it, it's just A, yeah. Alrighty. Next, here's a least squares regression model and correlation coefficient R. They were calculated for a set of bivariate data with variables x and y. Which of the following is closest to the proportion of the variation in y that cannot be explained by the explanatory variable? Whoa. Okay. What do we do? I mean, like, you have to think of a definition of something. The definition of that something is the proportion of the variation in y that can be explained by the explanatory variable. What am I talking about when I say that?
R squared.
That's R squared. Okay. So be careful, don't fall into the trap that I did this morning when working this problem. I saw R and I thought, okay, well this one's the proportion that cannot be explained, so I just did 1 minus 0.66 and I thought it was E. I even got so mad that it wasn't E, I looked back on AP Classroom to justify it. And then I realized my mistake. Is R squared 0.66? No. Get your calculator. Figure out R squared. So what is R squared? 0.4356. So listen really closely. That 0.4356 is not the answer. It's not D. That's the proportion of the variation that can be explained by the explanatory variable. So do 1 minus 0.4356 to get your answer of 56%. So that little tricky thing in there, I accidentally used R instead of R squared. And just kind of went a little too fast on this problem. So it's C. Kind of a funky way of asking that. All right, a botanist created a linear model, number 9, to predict the plant height from soil acidity for a certain type of plant. The slope is 2.5 centimeters. The standard deviation is 4. Oh, the standard deviation of plant height is 4. The standard deviation of soil acidities is 1. What's the value of the correlation coefficient? I hope you have some scratch paper handy, because this one's going to involve a little bit of writing. I'm writing down some stuff before I switch over to the document camera. Yes.
Did you just tell me to turn on R?
Oh, go to the catalog, so second 0, and then just go down to diagnostic on. When you get diagnostic on, hit enter, enter.
Okay, thank you.
Okay. I'm gonna get real fancy here. We're gonna do this on a sticky note. You can see that. There's a formula for slope that is R times the standard deviation of Y over the standard deviation of X. As a student, I'm piecing together the fact that, this problem gives me slope and a couple of standard deviations and one's R, so it's gotta be using this formula. It tells me that the slope is 2.5. I'm trying to figure out R. Now let's pause for just a second. There are 2 standard deviations, one for height of the plant and one for soil acidity. You have to understand what goes on top of the fraction and what goes on the bottom. So what might explain the other? Plant height or soil acidity? Soil acidity is the explanatory variable. It's your X value. So the standard deviation of soil acidity, did it say that was 1? That goes on the bottom. And the standard deviation of plant height, I believe it said 4, goes on the top. So basically that's 4R equals 2.5. Divide both sides by 4. In your calculator, 2.5 divided by 4 gives you 0.625 is the correlation coefficient. D. What if it had asked for the coefficient of determination? What's that? What's the coefficient of determination a fancy phrase for? Does anybody know? That's R squared. So all you would need to do is take this 0.625 and square it to get the coefficient of determination. Know your names for things. You might want to make some flashcards or something. Let's move on to number 10. Jordan is working on a business model for a sandwich shop. Based on past data, he developed this model. N hat represents the predicted number of turkey sandwiches sold in one day for a price of P dollars per sandwich. Which of the following is the best description of the slope? First of all, what is the slope of this line? -3. Okay, so the way that you always write about slope is for each increase of 1, which means A and B are out. For each increase of $1 in the X spot. So price per sandwich is in the X spot. So for each increase of $1 in the price of the sandwich, the number of sandwiches sold is predicted, and they all say the word predicted, to do what? Decrease by 3, increase by 3, or decrease by 150? Just decrease by 3. -3, decrease. Don't overthink it, it's C. For each increase of $1 in the price, the number of sandwiches sold is predicted to decrease by 3. Next, number 11. We're definitely going to get through this whole thing today, even if we have to finish it after lunch. Researchers are investigating how the amount of monthly rainfall measured in centimeters affects monthly growth in centimeters of a plant. From a sample of data, the researchers created a least squares regression line. Computer output is shown. Which of the following statement is an interpretation of the value 0.75? Is 0.75 the y-intercept or the slope? It's the y-intercept. So it's not going to have anything to do with the increasing by 1 unit business that A and B say. Those are out. Y-intercept is basically when you plug in 0 for X, it's your predicted amount for Y. and you plug in 0 for x. So it's gotta be C or D. You just have to stop and think about explanatory versus response and all of that. Rainfall is gonna help explain growth. When I plug, so that means rainfall is x. If I plug in 0 for x, or rainfall, then the monthly growth is expected to be 0.75. So that's going to be C. Oh my gosh, this one's really easy. Look at the scatter plot. Which of the following points is most likely a high leverage point? High leverage point, don't get it confused with outlier. High leverage means that it's really out far to the left or to the right. So hopefully you're kind of looking at that one in the bottom left corner, and you just need to pick the ordered pair that goes with that. What do you think? Perfect. A, yeah.
And 11 was C, right?
Yes. 13. If Q is removed, which of the following is likely not affected? Is Q an outlier or a high leverage point? It could arguably be both, but mainly it's an outlier. What won't be affected if we take Q away? R, whether the slope is positive or negative, the value of the slope, the sum of the squared residuals, or the net worth enters the y-intercept. What's not going to change if we take Q away? Right now, what is the slope? Positive or negative? Positive. If we take Q away, is that going to change it to a negative slope? No. So the sign of the slope is not going to change. It's B. So take a second before you just click B and move on and realize that, gosh, none of those, all of those other things are going to be affected if we take Q away. Let's keep going. Number 14. Oh my gosh, grab your calculator. I'm not going to read this whole paragraph. You see that equation there? Based on that equation that does have a natural log in it, which of the following is closest to the predicted selling price for a house with a size of 3,200 square feet? Be careful. It says that size is in 100 square feet, so don't plug in 3,200. What are you going to plug in instead? How do you plug in 3,200 as hundreds? What do you think you would plug in? That's the tricky part here. Does anybody know? Oh my gosh, you guys, 32. Plug in 32 because we're talking about how many hundreds of square feet that is, and there's 3,200. So I'm doing 2.08 plus 0.11 times 32. So on the right-hand side, I have 5.6. This is a natural log, so e to the power of 5.6 gives me my predicted price, and price is in thousands of dollars, so it's going to be B. We can actually finish before the lunch bell. Oh my gosh, look at this last one. See all those residual plots? Which one is the best one? The middle one, model 2, is the best. The residual plot for model 2 indicates that's the most appropriate among all of the models. C. Do it, submit it, get your 100. Hopefully you get 100, or that'd be really embarrassing for me.